So we learned how to solve by graphing, and then how to solve by substitution, and the final method is elimination. So the first example is a word problem. Two lines again can be represented by something in real life. And in this case, two baseball teams, the Eagles and Bears, are gearing up for the start of a new season. Both teams purchased new equipment at the same prices. The Eagles spent $975 on 4 bats and 2 balls, and the Bears purchased 2 bats and 15 balls for a total of $525. Determine the cost for a bat and a ball. So that's going to be our X and our Y. So it says, let X represent the price per bat. If a word problem doesn't have a let statement, then you should always write one yourself. And in this case, let Y represent the price per ball. So if we have two equations, X and Y are in both equations, 4 bats, 25 balls equals $975. The Bears now purchased 2 bats and 15 balls for a total of $525. What we don't know is how much each bat is and how much each ball is. That's what's missing from our information. So that's what we're going to find. Now, elimination is possible when we have vertically the same number twice. So we could have, for example, 2 4s for X terms, or we could have 2 25s or something like that in our Y terms. What looks easiest to me would be to leave the first line as it is, but multiply the second line by 2. If we did that, then we would have a 4x in the top equation and a 4x in the bottom. And that way we're going to be able to eliminate the x terms. So 4x, I'm just going to rewrite the first line, but the second line is going to get multiplied by 2. So we would have 4x, 30y, and 1050. And what we need to do when it's elimination is we need to decide whether we add or subtract in order to eliminate wherever we have the same coefficient. We have 2 4s. So a positive 4 and a positive 4, if we could subtract, then those would cancel out. 4 minus 4 is 0. 25 minus 30 is negative 5. So we have negative 5y. And 975 minus 1050 is negative 75. So we subtract vertically like you did when you were young. And in this case, we just need to divide both sides by negative 5. And we have half of our answer. We get y equals 15. So you know that y is the price per ball. So each ball cost $15. So it actually means something to us and maybe makes it a little bit more interesting. Now we're going to find out how much each bat costs. So here's the thing. We have part of our answer. We have y equals 15. It doesn't matter which equation you sub that back into. So I might sub y equals 15 right back into this equation here. So if 2x plus 15 instead of y, I'm going to write a 15. And that equals 525. So I know that 15 times 15 is 225. And I just have to solve this just like you solve an equation. So I would want to move 225 over with the 525. So what I'm going to have to do is subtract 225 from both sides. 2x equals 300. Last step is to divide each side by 2, and x equals 150. So what that actually means, when it's a word problem, it's a really good idea to not just say the ordered pair is 150 and 15, but to in words say, therefore, the price per bat is $150, and the price per ball is $15. Okay, you'd like to answer in a sentence. When it's a word problem and you're asked in a sentence, you should answer in a sentence. So to solve linear systems by elimination, there are some rules. One is that we usually express both equations in the same form, not quite standard form, where the x term plus the y term equals the number. That's pretty typical. We choose a variable to eliminate and multiply equations by a constant. We vertically add or subtract. So that's the big thing about elimination. We vertically add or subtract, and you have to decide if you add or subtract. You have to do whatever will eliminate the variable. And then you sub back in. So at the second part of elimination, it actually turns back into substitution to find the second variable. So example one thing I noticed about these two equations is that they're not written in the same order. So something that you might want to do is to write these equations in the same order, where vertically the x and the y would be in the same place. So something typical for the first one, it might look something like that. We bring the x to the opposite side. In the second equation, if I bring the x to the opposite side, it becomes a positive. The y is there, and then that equals 3. So just lining them up vertically would make a lot of sense before you start. And then you have to decide whether you add or subtract. In this case, my coefficients, my numbers out front, are both 1s. So in this case, you can either add or subtract. You can eliminate the x's and then you would add, or you could eliminate the y's and you would subtract. It makes no difference in this question. So I'm going to choose to add, okay, because that's a little different. Negative 1x plus x is 0, so they cancel out. Y plus y is 2y, and 1 plus 3 is 4. Divide both sides by 2, and y equals 2. And this is where elimination turns back into substitution. We're going to take y equals 2. If y equals 2, we might sub that back into the first equation. The first equation was y equals x plus 1. And we're subbing in y equals 2. So one thing we need to do perhaps is subtract 1 from both sides. So x is 1. Since this isn't a word problem, it's okay with me. We would just say, therefore, the solution is 1, 2, x, y, always in that order. Example 2. Example 2 is set up pretty nicely for you already. It doesn't have to be in a certain order necessarily, but we could just begin here by drawing our line underneath. We're going to add or subtract vertically, and what I notice is I have a y and a y, and that's good. The x terms, I have a negative 1x and a 2x, so I know that they will not cancel out. But if I subtract, the y's will cancel out. Y minus y is 0. Now, here's where it's important. This is a minus sign that you decided to put into this equation. So negative x minus 2x, negative 1x minus 2x is negative 3x. And 1 minus 4 is negative 3. Then what you could do is move the x term over to the left side, and it would become a positive 3x. And divide both sides by 3, so x is negative 1. That one looked a little different. It's in kind of a funny order, but it still worked out, and we get x equals negative 1. We would sub that back in. I want to show you what would happen in the first equation. If you sub in negative 1 for x, don't forget there's a minus sign already there. Then you sub in negative 1 for x. So that really means positive 1 plus 1. So our value for y is 2. So therefore the solution is negative 1, 2. So it did turn back into substitution. Example 3 is also not in a very good order. The terms aren't on top of each other. The x's aren't in line. So I might just switch these two terms around, and I'll rewrite what it would look like over here. So there's our first equation. They're not changing sides. They're just going to change the order. So they don't have to change signs. But that looks a lot better. We have vertically the x's in line and the y's in line. And we notice that the coefficients of these x terms are both 1. So we're going to go ahead and eliminate the x values. There's nothing you could do to 5 and 2, add or subtract. The y's will not eliminate in this case. So if we choose to add, because these signs are different, 1 plus negative 1, that cancels out. 5 plus 2 is 7. 3 plus 11 is 14. Divide both sides by 7, and y equals 2. And at this point, we sub it back in. You can sub it back into the first or the second equation. I might sub y equals 2 into the first equation. It just looks like it might be easier to me. And so wherever there's a y, we're going to write 2. And we end up subtracting 10 from both sides, so x equals -7. So our solution is -7, 2. The final example that we will do before the homework starts is to look at this one. This one is a really good example. So I really want you to look at this one because the coefficients of the x's and the y's are not the same. So you're going to have to mess around with this one a little bit and make both x's be 3, or you could make both y's be 4, because those two numbers, top and bottom, need to be the same if you want to eliminate x, but if you want to eliminate y, the 4 must also be a 4 on the bottom. So you have two choices, and sometimes that's hard when you have options. You can multiply the second line all by 2, and then you would have 2 4s, or you could multiply the second line all by 3, and you would have 3x and 3x. It's up to you. So I'm just going to pick it. I'm going to multiply the second line all by 3. I'm going to multiply by 3. The first line I'm going to rewrite exactly how it is already, but the second line, every single term has to get multiplied by 3. So we'd have 6y and 12. And when we eliminate, since we have a positive 3 and a positive 3, we need to subtract. 3 minus 3 is 0, so the x terms cancel. -4 minus -6 is 2. -4 plus 6. So we have 2y, and 12 minus 12 is 0. We would divide both sides by 2, and y equals 0. Now what we would do is sub that back in, so it turns into substitution. You can pick the first or the second equation. I kind of think the second equation looks easier. The numbers are smaller. So I'm going to sub y equals 0 into the second equation. And when I do, I get x equals 4. So therefore, the solution is 4, 0.